Hi, this is Alex from devstories.eu. Langflow, episode 2 of 15. You wire two nodes together, run your pipeline, and absolutely nothing happens. The connection looks fine, but the execution fails or throws a cryptic error. The problem usually traces back to how data moves between blocks, which brings us to component architecture and data types. A common assumption is that Langflow components pass loose JSON payloads back and forth like a standard web API. They do not. Every component in Langflow is a discrete, strictly typed Python class execution. A component contains an internal state, input ports, and output ports. Data flows strictly through these defined ports, and those ports demand specific Langflow objects. You can track these data types using port colors. Every port on a component has a specific color that corresponds to the type of data it accepts or returns. If you connect an output port to an input port and the colors match, the data flows seamlessly. If the colors do not match, you are attempting to pass incompatible data. The downstream component will not be able to parse the incoming object, and the flow will fail. To build reliable pipelines, you need to understand the three core data objects that travel across these connections. The first is the message type. A message object is used for conversational data. It carries the actual text content alongside routing information, specifically the role, which tells the system whether the text originated from a user, a system prompt, or an AI model. The second core type is the data object. A data object operates as a wrapper for unstructured information. It holds text content along with a dictionary of metadata. When you retrieve documents from a vector database, scrape a web page, or read a text file, that information travels through your flow as a structured data object, not as a raw string. The metadata dictionary allows you to pass source URLs or timestamps alongside the text without breaking the downstream processing logic. The third type is the data frame object. This is used for two-dimensional tabular data. It behaves much like a pandas data frame, making it the required type when you are passing parsed CSV files or structured rows and columns between analytical components. Because ports are strictly typed, you will frequently encounter situations where you have one data type but the next component requires another. Take the scenario of grabbing a raw text string from a basic Python execution block and needing to pass it into a text processing component that explicitly demands a structured data object. The port colors will not match. You cannot force a raw string into a data port. To bridge this gap, you use a type convert component. You place the type convert block between the two mismatched components. First, you connect the string output to the input of the type convert block. Then you connect its output to the data port of your downstream processing component. The type convert block takes the raw string, wraps it into a proper data object with an empty metadata dictionary, and passes it safely to the next node. Understanding the strict typing of these ports is the difference between a flow that works and a flow that constantly breaks. If a pipeline fails silently, do not debug your logic first. Check your port colors to ensure your components are actually speaking the exact same data language. Thanks for listening. Take care, everyone.